All right, folks. Here I am. I'm back again, ready to talk about the second part of yesterday's assignment. We're going to talk about circles and do some examples using kind of the basic properties of circles. So this is on circles. Okay. Let's get into it. So, first of all, what is a circle? Well, a circle, that's a good question. What is a circle? It's actually really interesting. When I ask a group of people, a group of students, what is a circle? They tend to say things like, oh, it's a round shape. I'm like, okay, well, what does it mean to be round? And they would say, well, it's a thing that looks like a circle. And I'll say, well, what's a circle? And they say, well, it's a shape that's round. Okay, and then we go around and around, so to speak, right? So what is a definition? What is the definition of a circle? Well, if you really want to be specific, which we do, we can say that a circle is the collection of points You're like, what? The collection of points? Bear with me. Okay, so it's the collection of points equidistant, meaning the same distance, okay, from a center, right? Which in this case, the center would be, well, more like this, right? Okay, so that's what a circle is. It's like if I pick a point anywhere in space and I say, give me all of the points that are the same distance from this point. Okay, well, here's one, here's one, here's one, here's one, right? You could do this literally forever, okay? But if you imagine finding every single point that is the same distance away from this center, then what you get is a shape that looks like a circle, okay? I should actually clarify here. It's the collection of points in 2 dimensions, right? If it's in 3 dimensions, we get a different looking shape, which we'll maybe talk about later. But there you go. That's what a circle is, okay? Now, some things about the circle, that actual distance between the center and the actual circle is called the radius, right? It's well, yeah, that's the R here, right? The radius is the distance from the center to the circle. Okay, the diameter. Okay, a lot of you probably already know this, but the diameter is the segment that intersects twice, right? So it hits the circle in 2 different spots, and it passes through the center. Okay, so again, I'm getting really kind of technical with my definitions, but at some point you have to. At some point we all have to make sure we're being as specific as possible when we're naming these things. We can't just say it's the thing that goes all the way across, right? That's not specific enough. It's a segment that intersects the circle twice and passes through the center. Doesn't get any more specific than that, okay? The circumference, okay, is the distance traveled if you walk completely around the circle. So it's kind of like the perimeter of the circle. And here's where we start getting into some formulas. The circumference of a circle is known to be 2 pi r, so 2 times pi times the length of the radius. Low key, sometimes people like to do it like this, where they just say it's the pi times the length of the diameter, same thing. And the last formula, the last thing about this is area of the circle is the length of the radius squared times this number pi, right? So these are the formulas that we're really going to use when we talk about these 3 questions here. But there's some other good information here, right? Definition of the circle, definition of diameter, definition of radius, and then of course our formulas here. Also, as is typically really well known, we will use when we need to plug in a decimal representation, a decimal approximation of the number pi, we will use 3.14. But sometimes we won't even do that. Sometimes our answers will be left in terms of pi, and we'll look at some examples that do that, right? So speaking of that, speaking of examples, let's get into the examples. I'm gonna erase all this stuff here. And let's see. Okay, number 11. Number 11 from this assignment. A basketball rim has a diameter of 18 inches. Find the circumference of the rim and the area that it encloses. Okay, so we've got this, basketball hoop, I suppose. And it's telling us that the diameter D equals 18 inches. Is that all that it says? Okay, find the circumference of the rim and the diameter that it encloses. Okay, well, if the diameter is 18, the radius is 9. And I don't really think there's anything more to say about it. We can just get right in and, starting with the circumference is going to literally just be the diameter times pi, right? Which is a legit answer, okay? But in the book it says to use pi equals 3.14, okay? So I guess if we just do that, let's just make sure that we did all this right. 18 times 3.14, 56.5. What does it say to round or anything? No, it doesn't. But to the nearest inch, 56.52 is about 56 inches, right? So there you go for the circumference. For the area, pi r squared. Well, radius is 9. Pi times 9 squared. 9 squared is 81. There's the exact answer. The area is 81 pi inches squared. Or if we use our approximation for pi, we get 81 times 3.14 is 254 inches squared. And that's it. So that's a pretty, basic example. There's a pretty basic application of the circumference and area formula for circles. Let's look at these next two and see if they get a little more interesting. I think they might. Let's see, what is number 13 about? Okay, so number 13. Okay, if 6 ounces of dough are needed to make an 8-inch pizza, then how much dough is needed to make a 16-inch pizza? Oh, okay. So let's first talk about pizza. Okay. I think what they mean when they say 8-inch and 16-inch is they mean the diameter, right? So here, diameter equals 8 inches, and here, diameter equals 16 inches, okay? All right. The thickness of these two pizzas is the same, okay? So we don't have to consider that. We're only considering the area, right? And I think this is a question that gets down to using ratios, right? So if our ratio is, let's see, area over dough, right? If that's our ratio, then we need to basically make a proportion by setting this ratio equal to this one, right? And I think it tells us, 6 ounces of dough to make this smaller one. What is the area of a pizza where the diameter is 8 inches? Well, that would be pi times the radius squared, which is pi times 16, right? Half the diameter is 8. 4 squared is 16, yes, okay. So the area of this smaller pizza is 16 times pi. So 16 pi over 6 ounces of dough, again, let me just double, 6 ounces of dough, is equal to the same ratio over here, except here the area is half of 16 is 8. 8 times 8 is 64. So the area over here is 64 pi. Okay, quite a bit different from this. 64 pi over the unknown amount of dough that it's going to take to make this pizza. Okay, so got this proportion. We don't need these anymore. Let's solve the proportion by cross multiplying and solving. If I cross multiply this way, I get 16 pi times x equals 6 times 64. 6 times 64. 384. 384 pi. Okay. Okay, so you might be wondering, how come I left the pi in there like this? How come I didn't turn it into 3.14? Well, I didn't do that because that would be doing extra work. Okay, because what I knew was going to happen in the end is I knew when I set up this proportion that the pi's would cancel. Okay, this pi over here cancels with this pi over here, and now we just have 16x equals 384. I can solve that by dividing both sides by 16, and I get x equals 24 ounces. Okay, and yeah. And I guess that makes sense, right? Because if you looked here, the area of this pizza is, well, actually the area of the bigger pizza is 4 times the area of the smaller pizza. This is 4 times bigger than this in terms of area. So that means I must have to use 4 times the dough to make this one compared to this one. 6 times 4, 24. So it all seems to check out. Great. All right, one more, and I think the next one is also about pizza. Let's see, number 17. Let's see here. Which is the better buy? A 10-inch pizza costing $5 or a 15-inch pizza costing $9? Okay, so we've got a 5-inch that costs, I already forgot. Oh no, a 10-inch costing $5 for a 10-inch versus 15 costing $9. 15-inch pizza costing $9. Okay, so this is kind of a legit real-world situation, right? I mean, if you're trying to get the most for your money, you see these 2 pizzas on the menu, you might sit down and think, well, which one's the better deal? Maybe it makes more sense to buy 2 of these as opposed to 1 of those. I don't know. Let's see. I think the thing to keep in mind is when you're buying a pizza, when you're eating a pizza, you're not eating, like, the diameter is not really relevant to the size of the pizza. What's relevant is the area, okay? The area of a pizza where the diameter is 10 inches is pi r squared, right? Which is 25 pi, right? Over here, half the diameter is 7.5. This I might need a little help with. 7.5 times 7.5 is 56.25. Okay, times 5. And we're trying to figure out what gives you the, like, we got to turn this into a ratio, right? We want to turn it into dollars per square inch of pizza. So this over here would be $5 over 25 pi versus $9 over 56.25 pi, okay? So I'm just comparing these numbers. Whichever of these numbers is like, well, let's see. If I divide these two, 5 divided by 25 times 3.14, that's 0.06, which is 6 cents per square inch. If I get this one, that's what I'm paying. Per square inch, I'm paying 6 cents per square inch. Over here, if I divide those, That's 9 divided by 56.25 divided by 3.14. That's 5 cents per square inch. So it's not a huge difference, but it appears, based on these calculations, that this one, the bigger pizza for $9, is the better deal. Yeah. So next time you order pizza, as long as the pizzas are circular, you can pull out this, this example and say, guys, I got the thing that's going to help us figure out, get the best deal. Or you can just, order the pizza, not worry about it, and pay the extra cent per square inch. In any event, I hope you like these videos. Or even if you didn't, I hope they were useful. I think I'll be making one more video later on today where we talk about some volume stuff. But until then, cheers everyone. I will talk to you later.